Hi, it's Mike. Welcome back to the shop. It has been a very long time since I've made a video. I've actually shot a few. I just never finished the editing or posting of them. So hopefully I'll get back in the swing of things. Life has changed a lot over the last 6-8 months. No longer married, so my priorities have changed. Anyhow, I'm going to try to make some videos now that it's almost winter. And in Colorado, it's definitely hasn't been fall-like. We've had a lot of snow and it's cold. So today, what I'm going to do is it's pretty simple. I'm going to we got this blowgun I bought, I don't know, a while back ago, and it's quiet, which is great. It's nice. The problem is that this is an annular discharge, and it's got a whole lot. There's no way this is going to show up on camera. Anyway, it's got maybe 30, 40 little tiny openings around this cone, which is great, except that you can't really blow out the inside of anything that's small, and it uses a large volume of air. So the project for today is we're going to make a new nozzle with an extension on it, maybe 6 inches, and of course they sell these and they're not very expensive, but what good is having a shop full of tools if you don't actually make something with them? So we're going to do this the hard way, and let me move the camera a little bit and we'll take a quick look at what we got. Okay, this blowgun is made by Legacy Manufacturing Company, which is a U.S. company, but I'm reasonably sure it's made in China. I think it had it on the package, which is fine. It's actually really well made. I have no complaints with the gun. It actually works really well, except for the fact that it uses a lot of air. And like I said, it doesn't have an orifice in the middle, so for blowing out small holes, it doesn't work very well. It's not bad. It's just not really what I wanted. Just like a new end piece for it. So to that effect, we're gonna make one. It's just threads on here, and near as I can tell, this is a 1/2-20 thread. So I did some measuring, and if you measure it, it is either 12.43 millimeters or 489 thousandths, 490 thousandths. I'm gonna turn that around, I guess. But anyway, it's pretty close to 1/2 inch. Taking a thread pitch gauge, this is a 20. It lines up pretty good, actually really good, and it looks right. But also a 1.25 millimeter pitch also lines up very close. And there's only, a little over 1/1000th of an inch difference between pitches, but it's 12.5 millimeters. It's a little bit too small to be a 13 millimeter thread, and really a 13 is not a very standard size. It goes from 12 to 14. So I'm going to go with the assumption that this is a 1/2-20. Now the outside dimensions of this are actually 16 millimeters and almost 16.78. So and they're absolutely not critical. It doesn't matter. I can make them whatever we want. This is pretty close to 3/8 of an inch in length. It is 0.378 inches, so close enough to 3/8, 358, depends where you measure it. So close enough as it makes no difference. So we're going to make a new one. Got some 3/4 inch 6061, just regular old aluminum. So we're going to make it about this long, and then the other part, the nozzle, we're going to make out of this, which is 1/4 inch OD, 1/8 inch ID steel tubing. And it's a little bit bigger than a 1/4 inch. It's about 3 or 4 thousandths oversized, and it's a couple thousandths undersized inside, which again makes no difference whatsoever as long as this will press into that. So basically a lathe project for today. The only question on what to do is whether or not to single point this on the lathe, which I may do because I really enjoy cutting threads on the lathe, or run a die down it. And I actually have a brand new 1/2-20 die. One of the hardware stores locally went out of business 6 or 7 years ago, and when they were doing so, everything was cheap. So I bought a whole box full of, not a box full, but a handful of dies. So this is, it's not high speed, but cutting threads on aluminum, not a big deal. The only downside is I do not have a hex-shaped die stock. So, I can use a wrench and hold it up with the chuck on the lathe, but I may just single point it. One thing we do have to do is accommodate this O-ring. So let's take that out and see what the groove looks like. Which I'm going to have to zoom in to really see this. But anyway, we've got a groove in here, and it's about 100 thousandths wide. Yeah, 98, close enough. So, and what's the diameter on that? 420. So, easy enough to replicate, and so we'll do that. And of course, instead of this kind of discharge, it's just going to have a hole, and we're going to press fit 6 inches of tubing into the end of it, or interference fit, or put it in there with some red Loctite. Either way. So we'll get this set up on the lathe and move the camera, and we'll get going. It should be a pretty simple project, but of course, plenty of opportunity for things to go wrong. Hopefully nothing will, but I did start a half 20 tap in the end of this by hand, and it threads in a little ways, but it's a little bit tight. Now, it could be that they just used a crappy tap when this was made, or it is slightly off. I don't think, as far as I can tell, that this tapers. So it looks like it's a straight piece, so it's not a pipe tap, and so as far as I can tell, it's just a half 20 thread, or a 12.5 millimeter by 1.25. Either way, I'm not entirely sure, but like I said, 12.5 millimeter, not really a very standard size. So I'm going to go with half 20, and it should be fine. So, and if it isn't, well, you get to watch. I do not have a fine pitch knurling tool like that, so I may not knurl it. But that's fine. It doesn't matter. It's not like it has to be tight on there. So anyway, let's get going. Okay, so we got a piece of 3/4 inch aluminum stock. It's, I don't know, 5 inches long maybe. Doesn't matter. So not going to do anything fancy. Just chuck it up and turn it down. Make sure we got enough. We need about 1.5 inches when we're done. It's a little to cut it off. So this is sticking out 2 1/4. That'll do. Let's give it a little twist. Should be running pretty true. Yeah, plenty good enough. We got to turn it down anyway. So, so I made a little chicken scratch drawing of the thing, and I'm just going to go 5/8 OD on the overall thing, on the overall piece. So I forgot to mark it on anyway. That's 1 1/4 inches. We've got another 3/8. So we've got 1 inch and 5/8 overall part, and this end will have the threads on it, of course. So get the OD turned down. It's been so long since I made a video, I don't know if I actually showed these, but I bought an actual pair of prescription safety glasses, so they're bifocals. Very dorky looking. They work really well. My other ones were fine. I never had a problem. But, then they were polycarbonate. They were shatter resistant. But I popped the couple. They were like $250. They don't give these things away, but they should last for years. And for doing woodwork and stuff where there's a lot of fine chips, they're a lot better. So anyway, we'll face this off, turn the OD, and then we'll drill it. So the diameter of the tubing is 253 thousandths. There's no standard, imperial size drill bit that size. The closest that you can come is a letter F, which is 257, which is too big, and of course 1/4 inch is 250. So we'll go with that, and maybe I'll end up putting the tubing in the lathe and just turn a couple thousandths off of it, because I'd like an interference fit, but 3 thousandths is way too much on something that small. So, all right. Anyway, we'll face this off and then turn the OD and drill it and and thread it. Shouldn't take too long. Show up. Yeah. Not too bad. Sure we got enough length. Yeah, that's just over 2 inches. That's more than enough. Let's see here. Just to get a baseline, we have 706 thousandths. I'm actually going to punch that into the DRO. I'm not going to worry about putting a center in this because it's not a precision part. It'll be fine. So that's should be about 649. According to the DRO, that should give us 625, real close, plenty close enough. Slowed the feedback down. All right, not quite as pretty as if we hadn't to interrupt it, but it should be fine. Hit it with a little emery paper, doesn't matter. 625 on the money, so that part's good. So now we've got to cut the part for the thread, which will be 375 length down to 490 diameter, and then we'll put a relief in it. Okay, so we're gonna single point this. So we need to go, at this depth. We'll put a relief in there, which will be for two things: one, the O-ring, and secondly, to give our threading tool somewhere to go. So we'll just zero off of this, face it, and make that our zero, and then use the DRO to go over 375. And, it's not critical. There's about 1.5 inches of threads inside of this, so if we go 1/2 inch, it's fine. So just touch off, face just a little off of here. Zero our DRO. And I'm going to move it over. I know this doesn't show up. So 375 on the DRO. Whoops, I bumped the camera. And then re-zero it. Just make a mark here. And we know the DRO's reading good. 625 on that gave us 625. So we'll go 550. We'll leave this 20 over and go 510 and then measure it and make sure I'm not going too far. Take a spring pass just to be sure. Okay, if this was a precision part, I'd get the micrometer out, but since it's just this, it's fine. We got 508.5, and the DRO says 509.5, so within a thousandth, that's close enough. We're just going to dial it down to 490 and call it good. Just, we could make it a little, I'm going to go 495, and then we'll hit it with a file to clean the threads up a little bit. Run this over manually, bring it out. Okay, so we're good on that, and get ready to go here. So I think we'll, I think I'm going to drill it first, and that way we'll get that out of the way. So we'll just spot it with a center drill. Because I want this hole to be a press fit. I'm not going to ream it, but I am going to start it 1/64 under and then bring it to the final size. Little WD-40. One more WD. When it's this deep, you can't go very far because it just packs up with chips right away. So we'll give it another couple hundred thousandths. That should be plenty deep. That should be about, I don't know, maybe almost 2 inches. Let's see where we're at. .76, so 1 3/4. That's good enough. We only need 1 5/8, so that should be fine once we cut it off. So we'll take and use our 1/4 inch drill and just bring it out a little bigger. We should be good there. Going to put a little countersink on the end for relief, and then we'll chamfer the end as well for the thread. And got a little copper on there. Okay, it doesn't show, I'm not going to move the camera, but anyway, there's a nice little chamfer on there. So we also need a relief in here for two purposes. One, for the threading tool to drop into, and for the O-ring. Our relief is pretty close to 93 thousandths wide, which is 3/32, which is what this tool is, I believe, but I should... Let's double check that and make sure that that's correct. Alright, let's see. That should show up on camera. No, this is a little narrower than that. This is 86.5. Oh, hang on a second. Yeah, we're zeroed. Yeah, 86.5, 87. So we'll go in with this up against the shoulder and then move it over 7 or 8 thousandths and widen it up a little bit. So we just touch the shoulder. Right there. We'll set 0 on the DRO. And we want on our diameter, we want 420. So we need to take about 60 thousandths off because we're at about, no, 70 thousandths because we're about 490, 495, and we want 420. So yeah, about 75. So anyway, I'm just going to touch this and 0 that. I'm going to take squealy. Put a center in it just for this. Maybe it'll squeal a little less. Okay, we'll go back to 0 on the DRO. So we're in the same spot. Oh yeah, it's a lot happier. So that's 50 thousandths off the diameter, approximately. Let's see where we're at. And 442, so we need to take another 20 thousandths off. So that'll be pretty close. Okay, that'll take us up to 4 to 70 thousandths on the DRO. Okay, that should be, let's let it rub for a minute. That should get us real close. It's not super critical. I would imagine within a few thousandths is plenty good. We got 424, so I'll take a couple thousandths more. It's about right, because I thought 75 and the DRO said 70. Okay, I'm sure that'll be good. Our slot's 86 wide, we want 93, so we need 7 thousandths more. So we'll just bring this over 7 thou. And just go in and let it cut on the edge until we get to depth. Which is right there. That's my old blowgun, which works, but I don't like very much. So check this just to be sure. 420 right on. So we're good there. And our width should be, let's see here. .93 thou. So we're good on the width. So we'll want to put a little chamfer on the inside of that and the outside for the threads, but I'll just use the threading tool for that. So that way we get a 60-degree angle. And I got to definitely check the square on this. It should be fine. I know this doesn't show up, but it is a little bit off. Not much. That looks really good. Just laid the side of the threading tool up against the jaw, so it should be good. So we'll just use this and put a little chamfer on both sides. Okay, now I gotta check, see where I got in the change gears for the lathe to see if 20's on the list of what I got. So I'll be right back.